I'm Dr. Muhammad Ali. In my publication, my name is Muhammad El-Hadedy. I'm Associate Professor at the ECE Department at College of Engineering at Cal Poly Pomona and Director of Reconfigurable Space Computing Lab. So it's really quite simple. We'll try to use the difference in the charge between the collector and the emitter for generating ionized area between of them that will be pushing the molecules of the air enough to create the thrust that it will help for moving and mobile robotic elements.
Hey, I'm Josh Madsen. I'm a 6th-year electrical engineering major. Behind the Ionic Thruster is that we are going to charge 2 electrodes, one with a very high positive potential and one with a low negative potential. The idea is that since there's this high potential difference, air will begin to act as a resistor. During that period, since we're charged to a high voltage, we're going to end up having ionization occur, which will also begin to show the effects of corona discharge.
The whole entire idea is to figure out what is the feasibility and study the whole entire concept of generating enough charge that it will be breaking the resistance of the air within the collector and emitter.
My name is Nicholas Reyes. I'm an electrical engineering major, and I contributed to creating a simulated environment for the project. So I created the simulated environment and worked on collector design in providing the most efficient output of our air that we get from the ionization area. So we were trying to achieve an improved ionic thruster from previous designs that we had seen, and also build an airship that was able to carry this technology and provide us some kind of lift or thrust to propel us forward.
I think in my opinion, the hardest part that we had to overcome was the transformer design itself. Trying to transform a low voltage DC signal into a high voltage AC or high voltage DC signal is quite difficult, especially doing it in a lightweight format. So when you try and configure a high voltage power supply like that, you end up needing a very big transformer in of itself. However, it's not very feasible. We went through multiple iterations of it, and we're not able to settle on an idea that we like best for our project other than going with pre-made transformers. The only issue with that is that while we were trying to run our tests at 40,000 volts, we ended up running around closer to 12 to 15,000 range.
My name is Matthew Cerna. I'm an electrical engineer. I worked on the power system for the project, so I did a lot of research on transformers, and I tried my best to make the best power system for our project. I think the biggest problem we had to overcome was definitely sealing the blimp. There was a lot of air holes, a lot of leaking. We tried everything we could to cover as much leakage as we could, but in the end, it was very hard to make something airtight.
David, what is your major?
My name is Daniel Penninger. I'm an electrical engineer. For this project, in the early phases, I contributed to doing research, understanding what is an ionic thruster. And in the later phases, I worked on trying to see if we can make it in a flight median, and we decided to go with a Zeppelin design, which I helped design and try to construct.
My name is Nestor Castillo Sandoval, and my major is electrical engineering. I helped with some testing, modeling of the collectors for testing, building the actual blimp or aircraft.
Artemis, it's a generation of Artemis. You know, the new generation of the students is actually pushing all the boundaries of technology.
I think the development of ionic thrusters definitely can eliminate the idea of fuel within space.
It involves a completely different form of flight that's not very well researched or understood, because from our research papers there was very little research into ionic thrusters and how they can be incorporated into an atmosphere.
I think in terms of the Artemis mission, it could be extremely useful. I mean, NASA has a lot more resources than we do. I'm not saying it's infinite, but it's a lot more resources than we were working with. I think that our study begins to observe, okay, how does this play out in an atmospheric condition? We take it to a lower atmosphere we should be able to produce those results if we were to pump in more gases or study what it is like at higher altitudes where we do have lower atmospheric conditions.